Okay, something new to learn today. Complement is basically some chance that something's not gonna happen. So it's a not. So this is definition. Probability of A complement is 1 minus probability of A. Huh? What does that mean? It means chance of something not happening is 100% minus the chance of something happening. For example, if you have a 70% chance of passing the class, then what's the chance of failing the class? 30%. How'd you get it? Well, 100% minus 70%. Or if you have a 1 out of a million chance of winning the lottery, what's the chance of not winning the lottery? 999,999 out of million. So it's just subtraction. Okay. If you have a 1 out of 7 chance of winning the ticket, then you have 6 out of 7 chance of not winning the ticket. Okay, right. So you could use percents, but in stats thingy, we don't use percents anymore. We use either fractions or decimal numbers because percents are for common people, normal people. We're advanced people. So number one, what's the chance of not A, which means complement of A, which means not A. So that would be 1 minus chance of A. Well, chance of A is 1 out of 12. So what's the chance of not getting an A? 1 out of 12. Well, not that is 11 out of 12. You could do 1 minus 1 over 12, but it's basically 12 over 12 minus 1 out of 12. Or just say there are 12 things. If chance of A is 1, then not A is 11. Okay? So keep going with that. If you notice, if you take all three of these, it's not 100% chance yet. So there's chance of D, E, F, G. There's more. So that will be number 5. If chance of A, B, or C is not exactly 100%. Okay, it's not 1. It's some other number. Okay, so number 3, find chance of A or B. Chance of A is 1 out of 12. Now, I did say it's a disjoint event, which means there's no overlapping. There's nothing joining them. They're completely separate. Like, red, blue. There's nothing in between. Well, that's not true. Okay. Um, it's there's nothing overlapping. So chance of A is 1 out of 12. Well, then it says or, which means we need to have more. So we'll be adding. And chance of B is 1 out of 3, so 1/3. So when you see the or, you'll be adding them when it's a disjoint event, when it's separate event. Okay. So that turns out to be, now you gotta, of course, change this second fraction. So it's 1 out of 12 plus 4 out of 12, which is 5 out of 12. And leave it in fraction form. I started you with fraction, so you should leave your answers in fraction form. Okay. And then number 8 is trick question. Okay, so what's the chance of either getting a B or not getting an A? So chance of B is 1/3. Chance of not A, we found that was 11 out of 12. We found that in number 1. So should we add those and we get something like 15 over 12 chance? That will be more than 100% chance, and that should not be true, right? I mean, only athletes can say there's 110% chance that we're going to win the game, because those are athletes. Those are, not math people. So in math class, the best chance we could get is 100% chance. That's it. You cannot go over 100% chance. So what happened was the B or AC. So here's A, here's B, here's C, and here's all the rest, like D, E, F, G. Okay, if it is not A, we already included B in the not A. This is not A, A complement. So A is 1 out of 12. Not A is 11 out of 12. B is already in there, so we don't need to add it again. So this turns out to be not a disjoint set, but this is joint set. Okay, B is joined with not A. So that's why the plus thing doesn't work. So the answer for this is basically not A. Not A is 11 out of 12. That's the answer. Okay, we already included 1/3 in here. This is 1/3. This is, 1/4, and the rest of them is here. If you add all those three numbers, you're going to get 11 out of 12. So, trick question. Okay, and then this should be a table question, which sort of review. Okay, what's the chance that you're going to get a Republican in this town? Well, there are 700 Republicans and there are 300 Democrats, which means there are 1,000 people who has been surveyed, or poll was taken from 1,000 people. So chance that you're gonna get Republican is this number, 700 over 1,000. So again, only time that you're gonna change that bottom number 1,000 is if you have a bar, the conditional probability, which will happen later. So that's just 0.7. Or you could leave it as 7 over 10, but reduce or change the decimal number. Then number 11 is not a Democrat. Think about it. Okay. Number 12 is Young and Democrat. So Young is here. So Young, but at the same time Democrat. So this is 200. There are 100 old Democrats, 200 young Democrats. And then there's Republicans. So that's 200 out of, what's the bottom number again? There's no bar, it's just an and. So small number 200 out of 1,000. Again, change to decimal number. Okay. And then if it's a Democrat or young, what's the chance that you're gonna talk to somebody who's Democrat or young person? Well, these are Democrats, 200 and 100. Young people are these, 300 and 200. So how many is that total? Well, 300 plus 200 plus 100, all three numbers, is 600. Don't add 200 twice. Okay, so we're just adding these three numbers. Backside kind of stay the same table, but with the bar now. So what's the chance that someone is a Democrat given that the person is old? So now we only talk to the old people. So somebody old is coming towards you. How do you know that someone is old? Well, he looks old, not young. So out of 500 old people, if you're old, well, what's the chance that you're a Democrat? Not 400, that's Republican. So that's 100 Democrat. So it's 100 because of the bar. It's not out of 1,000. The given that you already know that person is old, so that's out of a 500. Oh, turns out there are 500, 500. Well, darn. Well, anyways, 0.2 or 1 out of 5. Okay, so something else, number 15. What's the chance that you talk to somebody on the phone and that person happens to be a Democrat? So you're given that somebody is a Democrat. So out of Democrats, out of 300, what's the chance that that person is old? And that would be, again, 100. So bottom number changes if you have the bar. Okay, so that's 0.3 repeating, 0.33333. Don't put 0.3, that was wrong. It's 0.3 with the bar, or 0.3333 approximately. You need to make sure you are accurate. Okay, and then this one. So number 21 is quite complicated. You need to make your own table, just like you made one with the Democrats and young and old. So how do I make the table? We're basically gonna do just 2 by 2. Okay, so 90% of Scandinavians are blue-eyed, whereas 25% of English people. So we have two categories. There's a Scandinavian people, and then there's English people, and then there's blue-eyed. Oh, don't have a space. There's blue-eyed, and there's not blue-eyed, like brown eyes or red eyes. Okay, so 90% of the Scandinavian people are blue eyes. So, you know what? Let's just assume that there's 100 people total, 100%. So, in a certain company, here we go. In a certain company, 10% are Scandinavians and rest are English. So, out of 100 people, let's say 100%, but 10%, which means 10 people are Scandinavian, and rest of them means 90 of them are English. Okay, some European company. Okay, so 10 and 90 makes 100. That's totaling up together. Now, 90% of the Scandinavians are blue-eyed. So if there are 10 people who are Scandinavian in the company, 90% of them, or 9 of them, is blue-eyed. So by subtraction, how many are not blue-eyed? Only 1, because 9 and 1 makes 10. Okay, you cannot start with 90% on the Scandinavian. You gotta start with 100 people, and then out of 100 people working, 10 of them is Scandinavian, 90 is English. Out of the 10, because it says 90% of the Scandinavians, just like the condition probably. Okay, 90% of the Scandinavians are blue-eyed. Not 90% of the whole company. Okay, so what about English? 25% of English are blue-eyed. So it's a 25% of 90. I believe it's 2.5. Yikes. Well, one eye is blue and the other eye is brown. Okay, one person is. Anyway, so 22.5. So if you make it to 1,000 people, it would have been better. 225 people are blue-eyed, but this is just a random number that we chose, 100. So we gotta live with a half a person. Okay. And so 90 minus 22.5, which happens to be 17.5. Yeah, 17.5 is not blue-eyed, brown-eyed, or red-eye, or black-eye. Okay, so if you add them up, 22.5 plus 17.5 should be 90. Oh no, sorry. Sorry. I meant 67.5, right? There you go. 67.5 makes up 90. Okay. So here's a question. What is a probability that if you run into a blue-eyed person, so given that you could see that person has a blue eyes, you could tell. You're not colorblind, you could tell that person has blue eyed. Well, what's the chance that that person is from Scandinavian, not from English? So you don't be rude. You don't say, "Oh, you're blue-eyed. You must be Scandinavian." Oh, no, that's not true. Okay, it could be from England. Okay, so what's the bottom number? The blue eyes. So we need to add these two numbers. This 31.5 is the bottom number. And the top number, well, the bottom number here, the top number is Scandinavian. No, Scandinavian and blue-eyed together. So that would be this number right here, 9. So it's 9 out of 31.5. Okay. So calculator tells me that's 0.2857-ish. So that's only 28, maybe a 30% chance that you're right. So don't be rude. There's 70% chance that that person is from England. How come? Well, because, you're thinking 90% of Scandinavian is blue eye. So if you have blue eye, it must be Scandinavian. Nope, that doesn't work. You cannot flip it like that. Because there are more people working that are from England. Okay, so most people that you run into should be from England. Okay, so just because it works forward, it doesn't mean it's backwards. Okay, so if you see a Scandinavian, most likely he's blue-eyed. But if you have a blue-eyed, no, we cannot say he's most likely Scandinavian. We don't know that. Okay, all right, so that's it for today. Number 22, use a table also.